Hello friends, we are discussing the chapter Thermodynamics, and in the last lecture we have discussed about the positive and the negative work. And in today's lecture we are going to discuss the first law of thermodynamics. But before that we are going to discuss about the expression for the amount of work done in changing the volume of the system. Now, this is a system. This is a cylinder and gas is taken inside the cylinder. Now the cylinder is fitted with a piston. So this is the piston. This is the initial position of the piston. The piston, it is massless, it is frictionless, and it is movable piston. Because we don't want to discuss about the friction, about the weight. We don't want to discuss about other complications. Hence, the piston is massless, frictionless, and movable piston. Now, so this is a system, the cylinder. Now, let A be the area of cross section of the piston and A be the area of cross section of the cylinder. Let P be the pressure exerted by the system of the gas on the piston. किती pressure exert करते आहे? By the system on the piston. System आतला जो gas आहे तो किती pressure exert करतो आहे? तर P एवढा pressure exert करतो आहे. Now, initially the piston is here. So this is the initial position. Now, due to the pressure exerted by the system on the piston, हे pressure exert होता आहे. इथले सगळे जे atom molecules आहेत ते सगळे त्या piston वर pressure exert करत आहेत. So, due to this the pressure exerted by the system or by the gas on the piston has moved through a very small distance dx. Now this is the initial position of the piston, this is the final position of the piston. So the total force exerted by the system on the piston, now we know that pressure is equal to force upon area. So force is equal to pressure into area. So the force exerted by the system, by the gas which is inside the cylinder on the piston is F is equal to P into A. So this we take the equation 1. Now, because the pressure is exerted, because the force which is equal to P into A is exerted on the piston moves through a very small distance dx outside. So the piston moves through a very small distance dx. Naturally, work is done when there is displacement. So we know that the formula that work is equal to force into displacement. So now how much work is done here by the system? So the work done by the force, is W is equal to F into dx, because F is the force exerted on the piston and dx is the displacement of the piston. So dx. So this is equation 2. So from 1 and 2 we write W. Instead of F we now write PA. So FW is equal to P into A dx. We write PA from here. So this is the work done. Now, what is ADX? A is the area of the piston and dx is the displacement of the piston. So A ही त्याची area आहे आणि dx हे displacement आहे. So A into dx is the volume, is the increase in volume of the cylinder. आता त्या सिस्टीमचा जो, त्या सिलेंडरचा जो व्हॉल्यूम आता वाढलेला आहे. आधी पिस्टन इथे होतं, आधी पिस्टन असं होतं आणि नंतर ड्यू टू द ॲप्लिकेशन ऑफ force or application of pressure, the piston has moved here. So now this much volume is increased. So the area into dx will be the volume of the, will be the increased volume. So A into dx is equal to dv is equal to the increased volume of the cylinder. So now, so we can write work done is equal to, for this ADX, ADX च्या ऐवजी आपण काय लिहिलं? dv. So W is equal to PdV, where P is the pressure exerted by the system on the piston and dV is the increase in volume. Now, let VI be the initial volume. Initially volume किती होता? सिलेंडरचा VI होता. आता ड्यू टू द फोर्स एक्झर्टेड व्हॉल्यूम इन्क्रीज झालेला आहे. सो आता व्हॉल्यूम किती आहे? तर आता व्हॉल्यूम आहे VF. VF इज द फायनल व्हॉल्यूम ऑफ द सिलेंडर. सो द टोटल वर्क डन in increasing or in changing the volume of the cylinder. So the total work done, W, is integral of, we take the integration. आपल्याला माहिती आहे की we are using mathematics for solving the problems of physics. So for every short work done, so we are adding all the work done. So we are integrating. So W is equal to, from VI, volume कुठून चेंज झालेला आहे? VI पासून VF पर्यंत. So integrating from VI to VF, PdV. But we know that P is a constant pressure which is exerted on the piston, and hence P is taken outside integral of VI to VF dV. So now, putting the values, we get W is equal to P VF minus VI. So this much is the total work done when, due to the pressure, when pressure is exerted or when force is exerted in this direction and the piston moves from here to here, the volume increases, the displacement of the piston is dx, the increase in volume is dv, then the work done in changing the volume of the cylinder is P VF minus VI. The next point, we are going to discuss the first law of thermodynamics. Now, we are going to discuss the case 1, that supposing if Q is some amount of heat which is added to the system. म्हणजे एक सिस्टम घेतलेली आहे आणि त्या सिस्टमला आपण Q एवढी हीट सप्लाय केली आहे. नाव, सिस्टमनी कोणतंच कार्य केलेलं नाही. नो वर्क इज डन बाय द सिस्टम. ती हीट त्याला मिळाली पण but no work is done by the system. So all the heat which it gains is used for increasing its internal energy, increasing its temperature. So no work is done by the system. Therefore the internal energy of the system increases by the same amount. जेवढी heat supply केली तेवढ्याने internal energy increase झाली. So we can write delta U, that is the change in the internal energy, is equal to the amount of heat supplied. So this is case 1. Now case 2. Now, no heat is supplied to the system. Case 1 मध्ये आपण heat supply केली. But case 2 मध्ये no heat is supplied to the system. But the system, work is done by the system. System नी स्वतः कार्य केलं. System has done work. And for doing work, it requires energy. So from where the energy it has got? It has used the internal energy of the system. System ची internal energy वापरली आणि the work is done by the system. Now, the internal energy of the system will decrease because work is done. So, work is done to increase the volume of the system. So, the internal energy of the system decreases. By the same, जेवढं वर्क केलं गेलं तेवढ्यानी internal energy systemची decrease झाली. So we can write minus delta U. This is decrease in the internal energy of the system. This is equal to plus W. That is the work is done by the system to increase the volume. So also we can write delta U, हा minus फक्त इकडे घेतला, is equal to minus W. So Now in this way, the internal energy here in the case 1 is changed by giving energy, by giving heat from outside to the system, or the internal energy can be changed. Internal energy of the system can be changed by doing work by the system. So, from 1 and 2, the total change in the internal energy. आपण हे दोन्ही इक्वेशन एकत्र लिहिले तर how can we write it? So from both these equation, this 1 and this 2, we write this equation that is delta Q. We write this equation that is delta U is equal to Q minus W. So this equation tells us that the change in internal energy of the system is the difference between the heat supplied to the system and work done by the system on the surrounding. Also, we can rearrange this equation as U we take, W we take on this side. So, Q is equal to delta U plus W. So, this equation means that if Q is the amount of heat added to the system, the internal energy of the system increases by delta U and the remaining is lost in the form of work W, work done by the system on the surrounding. So these both statements are the statements of the first law of thermodynamics. Now we know that this Q and W can be positive, negative or zero. म्हणजे आपण हीट सप्लाय केली सिस्टमला किंवा सिस्टमकडून हीट काढून घेतली. सो सप्लाय केली म्हणजे इट इज सिस्टमने रिसीव्ह केली हीट, सो इट विल बी प्लस क्यू. सिस्टमकडून काढून घेतली हीट, सो इट विल बी मायनस क्यू. And if there is no heat is given, then Q will be equal to 0. Similarly, we have in the last lecture we have discussed about work, positive work and negative work or zero work. So this Q and W both can be positive, negative or zero. Hence this delta U, which is change in the internal energy, will also be positive, negative or zero. So now we are going to discuss the change in the internal energy of a system. So this is how there is an increase and decrease in the, or there is a change in the internal energy of the system. So this is a system and supposing Q amount of heat is added to the system. So Q heat add केली म्हणजे समजा आपण 200 joules, Q is 200 joules. So 200 joules of heat is added or energy is added to the system. So this, and the system does work. Systemनी कार्य केलं. Systemनी किती कार्य केलं? The work done by the system is 100 joule. So now we know that when the system does work, the work is positive. So this is 100 joule. And when the system receives heat, it is also positive. So this is 200. So we, according to the first law, according to the expression for the first law of thermodynamics, we write delta U is equal to Q minus W. So delta U is the change in the internal energy. So delta U is equal to Q is 200 joule is added to the system and W is 100 joule of work is done by the system. Hence this will be 200 minus 100, that is equal to 100 joules. So here we get the internal energy of the system increases by 100 joules. So delta U is greater than 0. In the next case, the system is the same, and in that system energy is released. Now this time energy is released by the system. किती energy release केली system ने? 200 joules. System ने energy release केली. When it absorbs the energy, when it absorbs the heat, Q is positive. When it releases the energy, releases the heat, Q is negative. So Q is equal to minus 200 joule लिहिलं कारण त्यांनी energy release केली, heat release केली. Also work is done. Work is done on the system. System वर कार्य केलं गेलं. सिस्टीमनी कार्य नाही केलेलं आहे, सिस्टीमवर कार्य केलेलं आहे. सो when the work is done on the system, the work is negative. We take the work as negative. When the system does the work, इथे सिस्टीमनी कार्य केलेलं आहे, मग वर्क इज पॉझिटिव्ह. इथे सिस्टीमवर कार्य केलेलं आहे, तर then the work is negative. So work W is equal to minus 100 joules because the work is done on the system. So again, from the first law of thermodynamics, we have delta U is equal to Q minus W. Now Q is minus 200 joules. Energy released by the system, so minus 200. And work done on the system, so minus 100 joules. So this is minus of minus 100. So 200 minus of minus is plus. So 200 plus 100, that is equal to minus 100 joules. So delta U is equal to minus 100 joules. म्हणजे इथे काय झालेलं आहे, the internal energy of the system, delta U is now minus 100 joules, that is delta U is less than 0. So the internal energy of the system has decreased in this case. Now we move to the next case, that is the third case. Now here the system, this is the system, and 200 joules of energy is released by the system. System ni bahar टाकली आहे. Heat or energy is released by the system. मग त्यांनी 200 joules energy bahar टाकली आहे, heat bahar टाकलेली आहे, म्हणजे Q will be minus 200 because this is energy released by the system. So Q is equal to minus 200 joules. So the system Q is minus 200 joules. Also work is done on the system. System वर कार्य केलं गेलं. And किती कार्य केलं गेलं? 200 joules इतकं. So work is done on the system. How much? 200 joules. So we write, now this work will be negative. So we write W is equal to minus 200 joules. So delta U, we know from the first law of thermodynamics, delta U is equal to Q minus W. So Q is minus 200 because the energy is released, heat is released. And W is minus 200 because work is done on the system. So minus 200 minus of minus 200. Minus into minus plus. So minus 200 plus 200. So delta U is 0 joule. So change in the internal energy is 0. इथे internal energy, system च्या internal energy मध्ये change झालेलाच नाहीये. In the first case, the internal energy of the system has increased. In the second case, the internal energy of the system has decreased. And in the third case, there is no change in the internal energy. So we complete this. Thank you.